Hey everyone. So last time we talked about the atmospheric system. Today we're going to be talking about how that system has been sort of thrown out of balance and the foundations of what is causing climate change. So, in terms of the global energy balance, which we talked about being that balance between how much solar radiation is coming in and how much solar radiation stays in the atmosphere versus escapes back into space. So, Earth's temperature changes are occurring for a number of different reasons. For one, there are some variations outside of human control that are due to solar radiation cycles that vary or are different over time. You also have things like global dimming, which could be based on both human and non-human created conditions, as well as feedback loops, which we'll be talking about today and is one of the most important concepts within this unit. And then finally, the enhanced greenhouse effect, which we also know of as global warming. So the first of these factors, the variations in solar radiation, are due to a change in the output of energy from the sun. And there's currently evidence of what are called Milankovitch cycles, which are 11-year solar cycles in which more or less solar radiation can end up occurring. And this can affect the seasonal and latitudinal distribution of solar radiation because that energy budget, how much energy the Earth has to spend, how much it's received from the sun, ends up changing. And this can be responsible for several things, including a rise in temperature or a fall in temperature, like things that initiate ice ages. So a change to the atmosphere through these variations in solar radiation end up disrupting the natural balance of the Earth's energy budget. And so this ends up affecting a lot of things about the weather and the climate as well. So the next of these factors is global dimming that could affect weather and temperature and climate. So global dimming is the reduction of the amount of light at the Earth's surface. And this is most often caused by air pollution. So air pollution particles get into the air, it becomes smoky in the air like smog, and so that blocks out the sun from coming to the surface. And so it's estimated that it's between about 4% and 20% worldwide of the changes in temperature are due to global dimming. And it can absolutely have a cooling effect, especially on the surface of the Earth. So because less radiation is getting through to the Earth's surface, we are going to feel it as being cooler. And it's possible that global dimming has been masking and been a masking effect of what would feel like a greater shift in temperature change due to global warming. Because we're not feeling the full amount of radiation that is coming to the surface if the composition of the air above us is smoky or smoggy. So, for instance, after 9/11, all flights were grounded. No one could fly for a period of 1 to 2 weeks. And during that period of time, the temperature rose an average of 1.1 degrees Celsius on the surface of the Earth, especially within the United States, as a result of less air pollution. And so, because of that, we sort of know that since we do a lot of pollutant, air pollution activities, that it's going to mask some of the immense temperature change that's going on. Another system that's going to be incredibly important for us to understand are feedback loops. So a feedback loop is a system where the outputs or the result of the system lead to either the system becoming amplified or inhibited. So there's two different types of feedback loops. The first one is positive feedback. This amplifies the system. This makes the outcome of the system continue the cycle more and more, but every time it gets worse and worse. The best way that I could explain a positive feedback loop is if you have ever been on like a Zoom chat or a Google Meet and someone else has the video in the background and it starts this echo effect where it starts going louder and louder until the person turns off the volume on the other screen that they have in their background. And so that amplifies the system. Every outcome of the system sort of makes the system worse. But you also have negative feedback, and that stops the system. That sort of makes the outcome makes the effect less worse, or slows it down in some way. And so feedback mechanisms do play a key role in controlling the Earth's atmosphere, and any changes to these particular mechanisms are likely to have implications for the climate. Because positive and negative feedback loops are both associated with changes in the mean global temperature. In terms of positive feedback loops, some positive feedback systems already exist in amplifying the issues of climate change. So for instance, if we're looking at one particular example, some scientists believe that the impacts of global warming may be greatest in tundra environments. So when we're talking about tundra, we're talking about areas that are close to the Arctic Circle or the South Pole, I guess, as well. Most times we talk about it in terms of places like Siberia or Alaska that are part of this tundra. So it is believed that the effects of climate change will be most noticeable in terms of winter warming. So as polar ice caps melt, they result in less ice, and that lowers planetary albedo because water is darker than ice. And so if the ice melts, that darker blue color of the ice is going to absorb more of that radiation. It's going to make things warmer because of that. And so there's less reflection from the ice back into the atmosphere. And so lowering the albedo increases the amount of solar energy absorbed at the Earth's surface, and it also leads to an increase in temperature as well. And as that increase in temperature ends up occurring, you have this layer of soil that's under the top layer within tundra environments called permafrost. And that just means that it's permanently frozen. And it's been frozen for hundreds, if not thousands of years, most likely thousands. And so in this permafrost, though, you have all of this vegetation that existed at one point that has been frozen solid. And so it has not, changed because it's been frozen in the ice. However, as the permafrost melts, some of that vegetation is going to start to go bad. It's going to start to rot. And so as it is rotting, it's going to release methane. And that methane is going to be released into the atmosphere and increase the temperature because methane is a greenhouse gas that absorbs heat quite well. And so out of this outcome of this particular feedback loop, things are then going to get warmer, and that's going to cause more permafrost melt and more ice melt, and that's going to further lower the planetary albedo, and that's going to lead to hotter temperatures. And so the outcome of this positive feedback loop ends up leading to a greater amount of heating in the atmosphere. So other mechanisms of positive feedback include the fact that increased carbon dioxide that's released from increased biomass decomposition. So biomass, are things like vegetation and stuff like that. Due to rising temperature, especially in forest regions, is going to lead to a further rise in temperature as greenhouse gases are added into the atmosphere. You also have an increase in the first cover in higher latitudes, and this is going to decrease albedo and increase warming as well. And then finally, these positive feedback loops, just as a cap on all of this, are associated with global warming, and they tend to involve very long time lags. And so by the time that the outcomes of these effects start to appear, the mechanisms may already be working in a way where it's going to become a lot worse a lot quicker. And so this may go past the tipping point where it's no longer a solvable problem and cannot be reversed. Now, we also have negative feedback loops. And so some negative feedback systems do exist in sort of stopping systems from being able to continue to go. And so if we look at a couple of them, this example right here, you have increased evaporation in low latitudes, especially as a result of higher levels of precipitation. This may lead to increased snowfall on the polar ice caps and could reduce the mean global temperature. An increase in carbon dioxide in the atmosphere could also lead to increased plant growth by allowing higher levels of photosynthesis, and that would slow down the heating of the Earth. And then increased plant biomass and productivity would reduce atmospheric concentrations of carbon dioxide. I know the QR code sort of cuts that off a little bit there. So a couple other mechanisms of negative feedback. One would be burning, and this leads to more aerosols in the atmosphere and reduce solar radiation at the surface. This could cause cooling. You also have increased evaporation, which also increases cooling as well, especially if precipitation follows. All right, so all of these things are leading into the system known as the enhanced greenhouse effect. Obviously, we talked about in last lesson how the greenhouse effect works to keep everything in balance. The enhanced greenhouse effect is what we call global warming. It's the effect of the impact of increasing levels of greenhouse gases in the atmosphere as a result of these human activities. And so when we think about global climate change, it's the change in the global patterns of rainfall and temperature, as well as sea level, as well as where habitats are, and the incidence of drought and flood and storms, which are all on the rise, that result from changes in the Earth's atmosphere. And again, this is blamed mainly on the enhanced greenhouse effect and on humans as well. So the increase in greenhouse gases is also linked to a couple specific human causes. For one, industrialization, as well as the spread of industrialization through factors and movements like trade and globalization. High-income countries are the most to blame in this, although countries in newly industrializing countries or labeled as newly industrializing countries are going to add to atmospheric CO2 as well as they become more and more industrialized and therefore giving off more pollutants. All right, so this is an incredibly important lesson. If you have any questions over feedback loops, both positive and negative, or the enhanced greenhouse effect, or even solar radiation and global dimming, please let me know. Have a great day.